Hello guys, and welcome to my channel. Now right here in this video, we want to integrate 1 over e to the power of x plus 1 over the x variable. Well, this is a pretty simple function. So the antiderivative of this function, we can go ahead and find it by simply making use of the change of variable method. So I'm going to try to change the variable from the x variable to variable u in order to reduce the complexity of this function. So I'm going to do that by saying let u be equal to the denominator, that is e to the power x plus 1. Because I recognize that if I should go ahead and differentiate this function, du, dx, we're going to have e to the power of x. You know, the derivative of the exponential function just remains the same, and the derivative of that one, which is just a constant, will give us 0. Alright. Now, you know that from this relationship between the u and the x variable, we can simply get it that to find x, if you subtract 1 from both sides, first of all, we're going to have u minus 1 is just e to the power of x. Well, from here, we can just take the natural logarithm of both sides, and that will give us the value of x. But let's just stop here for now. Okay, so let's plug these things back into the integral. You know that this du dx is du equals to e to the power of x dx. So plugging everything into the integral, we're going to have 1 over u, where e to the power of x plus 1 is just u. So we change that to u, right? Now in place of dx, we know that dx from here will become what? This will become du over e to the power of x. E to the power of x, alright? So that is just dx. So in place of dx, here we just put du over e to the power of x. So that is, let me put it down, du over e to the power x. So that is just it. Now, we did something nice here. We said that u minus 1 is e to the power of x. Remember that I said that we want to do a change of variable from the x variable to the u variable. So having this in this form, we still have an x here, which doesn't make sense. So we need to take away that function of x and bring in a function of u. Alright? So since e to the power of x is the same thing as u minus 1 only without the x, I can substitute that. I put u minus 1 in place of e to the power of x, and that will give us the integral of 1 over u times, now e to the power of x is just u minus 1, alright? Since it's in the denominator, we just put it down in the denominator. Okay, so we've reached this point. Let me continue over there. So from here, I can rewrite that as the integral of 1 over u times u minus 1, alright? Let me clean this one, write it here. We just integrate that over the u variable. Now, to integrate this function, we need to make use of partial fraction decomposition first, then we can go ahead and do some things for that. Okay, so from here, we know that 1 over this, that is u squared minus u, which is the same thing as 1 over u times u minus 1, those are the factors. We can find some constant a over u plus another constant b over u minus 1, such that the sum of those two fractions will give us this. So this is the decomposition, alright? The partial decomposition of this fraction here. Alright. So to solve for the values of a and b, well, I'm just going to do this using the cover-up method. Now, the idea is to make this particular fraction undefined, the denominator will be 0, right? So for the denominator to be 0, that means u will be equal to 0. So I'm going to substitute the value of u, which will make this to be undefined, into this one, covering this one up. So I'm going to take u equal to 0, then I'm going to go ahead and cover this u up, because if I plug it in to be 0, then I substitute 0 into the other factor. So that will be 1 divided by 0 minus 1. That is 1 divided by negative 1, which is just negative 1. And that right there is the value of a. Okay, we're going to do the same thing to find the value of b. To make this fraction to be undefined, u here is going to be 1, because the fraction will be undefined if u minus 1, which is the denominator, is equal to 0, which means that u will be 1. So we're going to come over here, cover up the expression u minus 1, then plug in 1 into the other factor. That will be 1 over 1. That is just 1. So that is the value of b. So that means that the antiderivative of 1 over u times u minus 1 over the u variable is the same thing as the antiderivative of a minus u, where a is just negative 1. So we put it down, negative 1, divided by u not minus u. We add it with, now, b divided by u minus 1, where b is 1, that will be 1 divided by u minus 1. And we integrate those fractions over the u variable. Okay, so here we can decide to split the integral, or we just go ahead and do it that way. So I'll prefer just to do it straight. So that will give us negative of the natural logarithm of u plus the natural logarithm of u minus 1, like this, alright? Okay, when you integrate 1 over u, you get natural logarithm of u. So this is just minus, we just put down the negative in front. And remember that we didn't start with the u variable, we started with the x variable, alright? And we can go ahead and plug that in like a backward substitution. So we know that u is e to the power of x plus 1. So I'm just going to put it down, minus natural logarithm of, in place of u, I'll just put e to the power x plus 1, like that, alright? Okay, plus the natural logarithm of, well, again, u minus 1, which is just this expression, is e to the power x. So I can just plug that in, e to the power of x. Well, we are almost done, in fact. Okay, well, there's one more thing remaining. The natural logarithm of e is 1, because natural logarithm is like saying logarithm to base e. So of e is going to be 1, right? So there we just have x. And in fact, this is minus, so let me just put the x in front to make sense. So that will be x minus the natural logarithm of e to the power of x plus 1, and we add an arbitrary constant to that. And that right there is the antiderivative of that given function. Okay, thanks for watching, and please subscribe to this channel.